This is section 3.7 about absolute value equations and inequalities. So this should be the title at the top of your notes. I repeat, this should be the title at the top of your notes. Okay, so our goal here is to solve equations and inequalities involving absolute value. So, absolute value. You can solve absolute value equations and inequalities by first isolating the absolute value expression, if necessary, then write an equivalent pair of linear equations or inequalities. So, step 1, isolate the absolute, that's an abbreviation for absolute, value expression. So that is step 1 in solving absolute value equations and inequalities, okay? So this is what that looks like. If you have the absolute value of x plus 2 equals 9, step 1, you isolate this. This is the absolute value expression, right? So we isolate that, subtract 2 from both sides, and we're left with the absolute value of x equals 7. So we have two different possibilities, right? Because absolute value is saying the absolute value of 7 could equal 7, right? And the absolute value of negative 7 also equals 7. So x is equal to both 7 and negative 7. If you're confused, just think back to what we know about absolute value, right? Absolute value is always positive. So if we have the absolute value of something negative, the answer is positive. If we have the absolute value of something positive, the answer is also positive, okay? And these, again, are the absolute value, the symbol for absolute value, the two lines on either side of the expression. But what if you have an expression more than just x? So if you had x minus 1, minus 3 is equal to 5. If we wanted you to solve the solutions of this absolute value equation. So step 1, again, you isolate the absolute value expression, which is this, right? So plus 3, and we get x minus 1, the absolute value of x minus 1 is equal to 8. So know that these are the absolute value signs, right? Okay, so to solve this, you just set the absolute value expression, x minus 1 equals 8, and x minus 1 equals negative 8. Okay, so you take the absolute value expression and you set it equal to a positive of this and then a negative of this. All right, and then you solve. So here we get plus 1, x can equal 9. That's one solution. Plus 1, x can equal negative 7. That's another solution. So you can always check by plugging these values back in. So if I take this x equals 9 and plug it in, 9 minus 1 is 8. Is the absolute value of 8 8? Yes. What about this one? If I plug in negative 7, negative 7 minus 1 is negative 8. Is the absolute value of negative 8 positive 8? Yes. So they both check out. Okay? So we can write this as a rule for our notes as the absolute value of A equals B, okay? These are just, and A can be any expression and B can be any number or expression. And this limit here would be B is greater than 0, but you guys, we'll talk more about that. But if that's the case, you then solve A equals B and A equals negative B, like we just did. Okay, so those would be, that's supposed to be an arrow. That and that. So that's how you solve these, and those would then be your two solutions. Okay, let's look at a word problem using an absolute value equation. So, starting from 100 feet away, your friend skates towards you and then passes by you. So let's say you are here, and your friend is over here, okay? And this is 100 feet. She skates at a constant speed of 20 feet per second. So her rate is 20 feet per second. Her distance d from you in feet after t seconds is given by d equals the absolute value of 100 minus 20 t. Okay? So that represents her distance after t seconds. At what times is she 40 feet from you? Well, we would just set this equal to 40, right? And that's going to tell us at what time is she 40 feet from us. Again, because this expression here represents her distance d from you. Okay? And we want to know when is she 40 feet from us. So you set that equal to 40, and then you solve the two separate equations. 100 minus 20t equals 40, and 100 minus 20t equals negative 40. That's a negative 40 over there. Okay, so again, it's the expression. You solve just for the absolute value expression, which this equation already had it for us all by itself, and then you set that equal to the positive of this and to the negative of this. Okay, so when you solve this one for t, you get t equals 3, and when you solve this one, you get t equals 7, and those are both seconds, right? That would be your units here. Don't forget them. So the solutions are 3 seconds and 7 seconds. So what is that answering? Your friend is 40 feet from you after 3 seconds, so when she's coming here, and then after 7 seconds, this is going to be on the other side, at those 2 points in time, she's going to be 40 feet from you. Okay, here's your practice problem. Another friend's distance d from you in feet after t seconds is given by d equals the absolute value of 80 minus 5t. What does the 80 in the equation represent? What does the 5 in the equation represent? At what times is she 60 feet from you? Okay, this is your first practice problem. So if you need help, look back at the previous problem, the example I just did, and that's going to help you. Okay, just a quick recap. Recall that absolute value represents the distance from 0 on a number line. Distance is always non-negative. So think if we have a number line like this is 0, say this is 5, and this is negative 5. This distance is 5, even though it takes us to negative 5. And this distance is 5, right? So that's absolute value. Distance is always non-negative. So any equation that states that the absolute value of an expression is negative has no solutions. Okay? Again, any equation that states that the absolute value of an expression is negative has no solutions. So let's look at an example. If we have 3 times the absolute value of 2z plus 9 plus 12 equals 10, and it just says what are the solutions? So we solve this for z, right? Okay, so we're going to isolate the absolute value expression. This is the absolute value expression. The 3 is not a part of it, right? Just what's inside the absolute value symbol. So minus 12, we get 3 absolute value 2z plus 9. And these can kind of just, you can think of this like the 3 is this little coefficient out here, okay? And so this is all equal to negative 2. So now, just as if this were parentheses here, we divide by 3, those simplify, and we're left with 2z plus 9 equals negative 2/3. Okay, so now you're going to solve this, but wait, it's a negative. So then you stop. And this is different, okay? Don't just keep going like we usually do. Absolute value is never negative. So since this answer here is negative, the answer is no solutions. No solution. Okay? So anytime you get to this point and you have the absolute value set equal to a negative number, you know your answer is no solution. So here's your next practice problem. What are the solutions to 3x minus 6 minus 5 equals negative 7? What are the solutions? Okay, now we're going to move into solving absolute value inequalities. If you need to hit pause before we move on from that last practice problem, go ahead and hit pause and solve that first. But now this is solving absolute value inequalities, which are a little bit different. So let's say we have 8n, the absolute value of 8n is greater than or equal to 24. Okay? So the inequality says that 8n is at least 24 units from 0 on a number line, right? Because absolute value is distance from 0 on a number line. Well, to be at least 24 units from 0, 8n can be less than or equal to negative 24 or greater than or equal to 24, right? So let's look at a number line, right? If we have negative 24, 0, positive 24, this value, 8n, needs to be greater than or equal to 24 spaces from 0. So it needs to be, 8n needs to be less than or equal to negative 24, right? It needs to be farther this way. Or 8n needs to be greater than or equal to positive 24. It needs to be farther that way. Okay? And then we solve these. So we get 8n is less than negative 24. Divide by 8, divide by 8. Oops. N is less than or equal to negative 3. Or over here we have 8n is greater than or equal to 24. Divide by 8, divide by 8. N is greater than or equal to positive 3. So those are the solutions in order to make this true. So if we were going to graph this, I'm just going to squeeze it in right here. If this is 0, this is 3, this is negative 3. It's going to be greater than or equal to 3 in shading that way, and it's going to be less than or equal, so it's solid, to negative 3 shading that way. That would be our graph. Okay, now you try one. This is your third and final practice problem. What are the solutions of 2x plus 4, the absolute value of 2x plus 4, is greater than or equal to 5? So solve for the solutions and then graph. All right, I'll see you in class.